The next question with problem number 2 right here says, how many terms does this have? Well, all of these parentheses might get confusing, but this actually has 3 terms. I will use my colored pens to highlight them. This is term number 1, because remember, a term can have multiplication in it. So this is the product of x squared and x minus 3. That's considered one term. This is the second term right here. And then this is the third term right there. The products are considered to be all part of one term. Now, if you were to distribute this, then you would have several more terms because we wouldn't have multiplication. We would have just addition and subtraction. So in this situation right here, this problem has 3 terms. And it says, what factor do all 3 terms have in common? So if you wrote this out just like we did the other one, this first term right here would have x times x, and then it would have x minus 3. This one right here would have 2x, and then x minus 3. And then this one right here would have 3 times x minus 3. So these two have an x in common, but this one doesn't have an extra x. This one has a 2, but neither one of these do. This one has a 3, neither one of these do. The only thing that they all have in common right there is that x minus 3. So what factor do those have in common? X minus 3. And so now they actually want us to factor it. So this problem right here becomes that x minus 3 becomes the GCF. The x minus 3 is the thing that can be factored out, and when we factor it out, what does that leave? Well, in this first term, it leaves x squared. In the second term, it leaves 2x, and in the third term, it leaves minus 3. Is this problem completely factored? It may be, but then again, it may not be. This looks like it might be able to factor. Why? Because it has 3 terms. It's a trinomial, and it's a quadratic. So the leading coefficient right here is 1. So if you're over here using this chart, does it have a GCF? No. How many terms does it have? 3. Is it a perfect square trinomial? No. Is the coefficient 1? Yes. Then it must be one of those easy factor tables. So all we need then is factors of -3 that sum to be 2. So that's what we're looking at. So factors of -3. The only thing I know is 3 and -1, or -3 and +1. 3 is a prime number. They need to sum together to be +2. A +3 and a -1, that's a +2. A -3, that's a -2. So it looks like this is the pair that we're looking for. So this then factors into x plus 3 and x minus 1. Don't forget to bring that x minus 3 down. So this is the final factored form of that problem.